Covalent bonding in organic compounds. Have you ever attended a get-together where the requirement is to bring and share? Have you ever?
Yeah.
How did it go?
So it was quite interesting because everyone was asked to bring something. So I would take something along. I took something along. Then my friend also brought something. So we ended up sharing it. So say I took jollof to that gathering, and my friend brought maybe a pizza. So she'll share her pizza with me. I'll share my jollof with her. Then we end up eating together. Then we'll all be satisfied.
Even for myself, I remember the last party or get-together I attended was Bring and Share. And I think Bring and Share parties are more interesting.
Yeah.
Because you contribute something to the success of the parties. And also.
Yeah.
There are also some other parties where people just go empty-handed. And they just go to eat.
That one's also there.
That one is also there. Which one do you enjoy the most?
Actually, Bring and Share is quite satisfying. So you feel like you were involved in it.
Bring and share. You bring, you eat parts. Someone else will bring something, eat part of what the person brings, right? Yeah. Do you know atoms also do the same thing?
Yeah. And it's quite interesting.
Yeah, atoms also do the same thing, a kind of union or bonding known as covalent bonding. So atoms behave like those kids in school. During lunchtime, you have your snacks. Then he asks you, what have you brought today? And then you open your snack box or bag, whatever it is. And then you share what you have all brought together. Kids do that, right?
Yeah.
Atoms also do the same thing. They share their electrons in order to achieve stability. So the purpose of sharing is to achieve what? Stability. And the purpose of sharing their snacks is for them to become satisfied, to become full, right?
Yeah.
So when it comes to bonding in atoms, the type of bonding known as covalent bonding only has to do with sharing of atoms to achieve stability. And in order to achieve stability, we have two rules. It's either duplet or octet. For duplet, the atom must have 2 electrons in the outermost shell. For octet, it has to be what? 8 electrons in the outermost shell. Good. So an example of a compound that shows covalent bonding is hydrogen fluoride. So for hydrogen fluoride, it's a bond between hydrogen and what? Fluorine. Hydrogen has to satisfy the duplet rule, meaning it needs 2 electrons in its outermost shell to be full. But how many electrons do we see out here in hydrogen?
Hydrogen has only 1.
It has only 1 electron. So that means it's not stable. It needs 1 more to be stable. What about fluorine? How many electrons do we see in its outermost shell?
7.
7. Yes, that's 7 of them. But it has to be 8. Meaning fluorine needs an extra 1 electron to become what? To become stable. So do you think hydrogen will be willing to give out its electron to fluorine? No. And fluorine also not give out its electron to hydrogen.
Yeah.
So what will they do?
So they'll end up sharing it.
Good, they'll end up sharing. So what happens is they move close and overlap. And then they each contribute 1 electron. And then they share that 1 electron. So this kind of bonding is known as covalent what? Covalent bonding. So this is how hydrogen fluoride is formed. So as they share this way, they both become satisfied. And this is completely different from ionic bonding. Ionic bonding is seen in sodium chloride. For ionic bonding, they do not share, but rather one gives and the other takes. Look at sodium chloride. Sodium has 1 electron in its outermost shell. How many electrons does chlorine have?
Chlorine has 7.
7. For sodium atom to be stable, it needs extra 7 atoms to become stable. 7 is too much. So you do prefer to give that 1 electron to chlorine because chlorine needs only 1 to be stable. So when it gives that one to chlorine, they will not come together to form a bond. And that bond is known as ionic bond. So this is what happens. Sodium gives the one electron to chlorine. Chlorine accepts it, and the two of them form sodium chloride, which is salt. Okay. So that is ionic bonding. And this is completely different from what? Covalent bonding. Now we are talking about covalent bonding in organic compounds. So how do we see covalent bonding, or how does covalent bonding happen in organic compound? For that, we have to focus on carbon. Carbon has 4 electrons in its outermost shell. So how many more electrons does it need to become stable?
That means it will need 4 more.
So carbon will need 4 more electrons to reach 8. And that 4 extra electrons can come from any other atom willing to share its electrons. But for purpose of explanation, we'll assume those 4 electrons will come for 4 separate hydrogens. So this carbon will need 4 separate hydrogens to form 4 covalent bonds. So this is what? Covalent bonding. But when it comes to organic compounds, the covalent bonding, we have 3 flavors. So we will be discussing the flavors one after the other. The first flavor that we have is what?
The single bond, also known as the sigma bond.
Single bond. So single bond in organic compound. Let's see how it is formed. So what is it?
So it's a type of bond which is formed when 2 atoms share 1 pair of electrons.
Good. 1 pair of electrons. That means how many electrons we have out there?
They are going to share 2.
Good. That's what is referred to as 1 pair of electrons. So this is formed as a result from what? Head-on overlap of what? Atomic orbitals. This like 2 goats having head batting, or 2 sheep having head batting with each other. So we are going to use 2 carbon atoms to explain that. So now each of these carbon atoms has how many electrons in the outermost shell?
So they each have 4 electrons in their outermost shell.
So they each have 4 electrons in their outermost shell, which means none of them is stable. So they have to form covalent bond to attain stability. So this is what happens. The 2 carbon atoms move to overlap. So as they move to overlap that way, they share that pair of electrons. So that is what is shown by the line between the 2 carbon atoms. This is a single bond. Head-on overlap to share electrons. Now, after they share that pair of electrons, each of them still has 3 unpaired electrons. Do you see it now?
Yeah.
Good. Each of them has 3 unpaired electrons. So what that means is they need to bond with 3 separate atoms each. And for this case, we are going to use hydrogens. So this is what happens. Each of the hydrogens is going to move to overlap with each of the carbon they are attached to form bonds. So the first hydrogen moves to form 1 carbon-hydrogen bond. The next hydrogen moves to form another carbon-hydrogen bond. Then the third moves to form another carbon-hydrogen bond. And the process repeats until all the hydrogens overlap with the carbon. Now our focus is on the carbon-carbon bond here. What type of bond is that? It's a single bond. And the single bond is sigma. And the same sigma bond is formed between the carbon and the hydrogens. So you can see that this is a classic example of an ethane, an alkane, specifically ethane, with carbon-carbon single bonds. So this is how a single bond is formed, head-on overlap. A single bond involves the sharing of what? One pair of electrons. Good. Now, single bonds or sigma bonds have some features. What are those features?
So sigma bonds are strong and they are found in alkenes, which are saturated hydrocarbons.
Good. They are found in alkenes. Look at the bonds. Only single bonds are present. So one fun tip we have to take note of is this.
that sigma bonds are the first bonds to form between atoms during covalent bonding. And every multiple bond must have one sigma bond as its base.
And when we say multiple bond, what do you mean?
So we mean the double bond and the triple
Good.
bond.
Double and triple bond. So take note of the sigma bonds are the first bonds to form between atoms during covalent bonding. They are always the first bonds to form. So now let's look at the first example of a multiple bond, that is double covalent bond. A double covalent bond has how many sigma and how many pi bonds?
So it has one sigma bond and one pi bond.
Great. So what is a double covalent bond?
So the double bond is formed when two atoms share two pairs of electrons.
Share two pairs of electrons. And how this happens is there's one sigma bond and there's one pi bond. So we are going to use this carbon-carbon to explain that again. So look at this. They both have 4 electrons in their outermost shell. Not stable. They need 4 more to be stable, right?
Yeah.
So they can only get that through covalent bonding with other atoms willing to share. So these two carbon atoms overlap with each other in this order to share that one pair of electrons. So they share the first pair. And that is shown by the red line between the two carbon atoms. So that is the very first bond form, which is sigma. And it doesn't end there. Each of the carbon atoms has 3 unpaired electrons. So that means each of them need to bond with 3 separate atoms. But instead of bonding with 3 separate atoms, they each bond with 2 separate atoms, specifically hydrogen in this case. So the first hydrogen moves to overlap with the carbon to form the first carbon-hydrogen bond. The second hydrogen also moves to overlap to form the next carbon-hydrogen bond. The third does the same thing, and the fourth also does the same thing to overlap to form the fourth carbon-hydrogen bond. So does it end there?
No.
Why?
So we are left with 1 electron each on each carbon.
So those are the unpaired electrons. So those unpaired electrons will now come close to overlap sideways this way. And that is what to form the next bond. So these two bonds are known as the double bonds. So there's first a head-on overlap to form the red bond indicated in the first sigma bond indicated in red. Then there's a sideways overlap of the unpaired electrons. So this is how a double bond is formed. And for clarification, take note of this. Hybridization helps us to understand this kind of bonding. This is a high-level simplification of how pi bonds and sigma bonds are formed. But for better understanding and clarification, future videos will target hybridization to explain that for us. Now, double bonds also have some interesting facts. Is that for the double bonds, one of them is a what?
It's a sigma bond and
Yeah,
one is a pi bond.
It's a pi bond. And they also have some interesting features. What's that?
So the double bonds are stronger than a single bond, but they are less stable than 2 separate sigma bonds.
Good.
And they also increase reactivity.
Good. So there's an increase in reactivity in double bonds as compared to single bonds in alkanes. So if you look at the fan tip we have out there, what do we have?
So the pi bond in a double bond is weaker and more reactive than the sigma bond, making the alkenes more chemically active than alkenes.
Good. So pi bonds are weaker. Sigma bonds are stronger. Good. So alkenes have 1 pi bond, which is weaker, making them more reactive than what? Alkenes. So that's all we have for now on double bonds. Now we are moving on to what? Triple covalent bond. 1 sigma and what?
2 pi bonds.
Oh, good. 1 sigma and 2 pi bonds. I think I nearly slipped out there. 1 sigma and 2 what? Pi bonds. So let's look at what the triple covalent bonds are.
So that one is formed when two atoms share 3 pairs of electrons.
Good. 3 pairs of electrons. So how it's formed is there's 1 sigma and
2 pi bonds.
2 pi bond. And the sigma is head-on overlap. And the pi bond is what?
The side-by-side
Side overlap of orbitals. Side-by-side overlap. And then head-on overlap. But we understand that we're using this diagram. So we have carbon and carbon, 2 carbons. Now the first step, remember a sigma bond is always formed first.
Yeah.
And how is it formed? Head-on
Overlap.
So the 2 carbon will have head-on overlap. So that head-on overlap, there is 1 pair of electron that is shared. That forms the first sigma bond. And sigma bond forms the foundation bond in multiple bonds. But now, we still have 3 unpaired electrons each for the carbon atoms. But instead of they bonding with 3 atoms each, they only bond with 1 each. So for the first carbon, the hydrogen moves to overlap with the carbon for them to share that pair of electrons to form the first carbon-hydrogen bond. Then the next hydrogen also moves to overlap with the carbon to form another carbon-hydrogen bond. But does it end there?
No.
What happens? Or do we have any other electrons out there?
Yeah, so there are 2 electrons each on each carbon.
So each carbon has 2 unpaired electrons. So in total, I have 4 unpaired electrons. So this is what happens. The 4 unpaired electrons, the ones at the top, they move side by side and overlap to form 1 pi bond, shown by the blue line at the top. Then the unpaired electrons at the down also move side by side to overlap to form the next pi bond at the down. So at the end, how many bonds do we have?
So there are
3.
3
Look at this.
bonds. So 1 being a sigma bond and 2 being pi bonds.
2 being pi bond. So this is how a triple bond is formed. Do you think it's difficult for our students to understand?
Nope.
Very easy, right?
Very easy.
And then the fact is this. Like I said earlier, this is a highly simplified explanation of how pi bonds are formed. For better understanding of the orientations of atomic orbitals, hybridization is going to do the explanation. But that will be in future lessons. So if you've watched to this point, please subscribe to our channel so that those kind of lessons that we have plans for recording in the future, you wouldn't miss them. Now for triple bonds, 2 are pi and 1 is what? A sigma bond. We've already established that fact. So what are the features of triple bonds?
So triple bonds are very strong and short.
Good.
And they are even more reactive than alkenes due to the 2 pi bonds.
Good. Because pi bonds are reactive. And if our alkynes have 2 of them, that means the reactivity is going to increase. We have a memory tip for remember what we discussed so far.
Okay, so we always remember that a single bond is formed between 2 atoms. And there is only 1 sigma bond. A double bond is formed between 2 atoms where we are having 1 as being a sigma bond and 1 as being a pi bond. And a triple bond formed, you are going to have 1 being a sigma bond and 2 being pi bonds.
Thank you very much. Well said. Well, so that's what we have. We have single bonds. You see the carbon-carbon, there's only 1
sigma bond.
What about the double one?
So there is 1 sigma and 1 pi.
What about the triple bond?
1 sigma and 2 pi.
bond. So I think formation of double, single, and triple bond should be a work in the park for us. And with the little explanation we give you, I think that should clear out so much doubt for our student. But what is the result of covalent bonding in organic compound? What is the result?
So it leads to organic compounds forming molecules and not ions. They generally have low melting or boiling point, and they are non-conductors of electricity.
So covalent bonds. Now, for conclusion, we want to understand some key terms. Molecules and ions. What are molecules?
Molecules, they are a neutral group of atoms which are held together by covalent bonds.
While ions are charged particles formed in ionic compounds, not typical in organic compounds. So ions are not typical in organic compounds. So this brings us to the end of covalent bonding in organic compounds. This is an intramolecular force between the atoms in a molecule. In an earlier video, we explained the difference between intermolecular and intramolecular forces. If you haven't watched that video yet, check the description below this video to watch that, because we'll leave a link to that video. And then in that same video of the bonds found in organic compounds, we spoke about intermolecular forces. And the examples, one of them is dipole-dipole force or dipole-dipole interaction. That will be our next lesson. So our next lesson will be on dipole-dipole interaction. So if anyone hasn't subscribed yet, what should they do?
Please subscribe to the channel and always share, like we talked about earlier. So share with your friends, like the video. If there are any questions, please drop them in the comment section.
Okay. So dipole-dipole interaction organic compounds. What should you expect? Well, in that lesson, we'll be explaining what a dipole is. We'll use interesting interactive images to explain what dipole is. So I think you like to miss it, right? So come back and watch our next lesson. See ya.
Bye.